In the previous video, we talked about differentiation, but we specifically looked at the exponential rule. So the exponential rule for function says that if you've got a function that's in exponential form, x to the power of n, so a, which is any real number, x to the power of n, the derivative of this function would be a multiplied by n. So what you will do, you'll multiply the a with an n, and you'll subtract 1 from the exponent. So in this case, we will get a to the power, a multiplied by n, x to the power of n minus 1. So we talked last week or the previous video that you can then get the derivative of any function. Let's take an example, 5x to the power of 3. The derivative of this would be 5 times 3, which is 15, x to the power of 3 minus 1, which would be 2. And we also talked about that you need to rewrite your equation in an exponential form if it is not an exponential form. So to give an example, if you've got 1 over x to the power of 3, that would become x to the power of minus 3. And if you've got the third power of x squared, this would become x to the power of 2 over 3, or 2 to the power of 2/3. So if we look at the chain rule, just to give you another example, last week we also said that if you've got a function, let's say x plus 1 to the power or squared, you need to write this as multiple terms that is in exponential form. This would be x squared plus 2x plus 1. Then you've got 3 terms that's in the form of the exponential rule, and you can then get the derivative of this function, which would be, let's say the derivative of this would be 2x plus 2, and then the constants become 0. Remember that a linear term would be, you just use the coefficient, and for a constant it will always be 0. The reason for that is x to the power of 0, 0 times 1 is 0, and 0 times anything is 0, so that will just be 0. And for linear term is 2 times 1, which is 2, and you subtract 1 from the exponent, which would be x to the power of 0, which is 1, and that's why the constant will just be 2. So today we're going to look at the chain rule specifically. So for the chain rule, what we're going to say is, if you've got a function which is a composite function, so there's a function that's within another function. Example would be the one that we've done just now, x plus 1 to the power of 3, for instance, or if you've got the square root of 2x squared minus 1, or if you've got 1 over either a normal term like this, or you've got a algebraic function with a square root of x to the power of 3 plus 2x, for instance. These are all examples of where there's one function that's within another function. So just as with the exponential rule, we will rewrite these, of course, to be in exponential form. But you can see in all of these cases, we've got a function, an inner function, which in this case would be gx, and an outer function, which would be, in this case, x to the power of 3. So the inner function would be x plus 1. So if you substitute x plus 1 in x to the power of 3, you'll get x plus 1 to the power of 3. So we've got one function, an inner function gx, and an outer function fx. So what we want to do now is we want to just make some space. We want to get the derivative of this function. And the derivative of this function, so if we get the derivative here of this function, it would be the derivative of the outer function multiplied by the derivative of the inner function. Okay, so let's take this example that we've just shown you now. So let's take x, let's make it x to the power of 3 plus 5x to the power of 5. So we've got an inner function, which is this part, and an outer function, which is the something to the power of 5. So if this is fx, and we want to get the derivative here, we're going to say, okay, let's take this whole part here as something to the power of 5, and we derive that. So similar to what we would do for x to the power of 5. So for x to the power of 5, that would be 5x to the power of 4. So we're going to do the same thing here. We're going to say 5. The middle part stays the same. And now we're going to have to the power of 4. So the chain rule says that you also have to multiply this with the derivative of the inner function. So this part, the derivative of that part would be 3x squared plus 5. And that is the chain rule. So this applies for any type of function. So if we've got a, let's take the most advanced example that you'd use for this type of rule. Let's say you've got 5 over the square root of x squared plus let's make it 5x to the power of 3. Okay, so let's get the derivative of this. So again, we'll rewrite this first in the form that's an exponential form. So we're going to say that is, so this part will be this bracket to the power of a half. But then we move it to the top, so it gets a negative exponent. So it's going to be x squared plus 5x to the power of 3. And that would be to the power of minus a half. Let's make it minus a half. Okay, so remember, the square root is always to the power of half. So what we're going to do now is now we can get the derivative. So let's say the derivative of this function would be then, we always multiply the exponent with the coefficient. So it's going to be 5 multiplied by minus a half, which would be minus 5 over 2. The middle part for the first part of our answer would stay the same. And we'll subtract 1 there, so this will be minus 3 over 2. And then we need to multiply it by the derivative of the inner function, which would be 2x plus 15x squared. And that is the answer of our chain rule. Feel free to do some exercises, and then you'll get to know what the chain rule and the exponential rule for derivatives look like.